So I welcome you students for this quick survey of NCERT textbook on the isomerism of coordination compounds, and they have discussed about the two types of isomerism: stereoisomerism, geometric and optical; structural isomerism, only 4 variants. And as far as geometrical isomerism is concerned, we have already learned that square planar complexes where coordination number 4 of type Ma2B2 can show geometrical isomerism, and they can exist in cis and transforms. We agreed it as cisplatin, a cancer drug, and we agreed that it is transplatin, which is a poisonous material. And square planar complex Ma, B, C, D, all ligands are different, means it exists in 3 geometrical isomeric forms. And square planar complexes never show what is called as optical isomerism. And then we also have seen a tetrahedral complex can never show geometric isomerism, but in a tetrahedral complex, if all the ligands are different like A, B, C, D, then it can be optically active. Normally in competitive exam they are asking in a particular complex of type M, A, B, C, D type, it exists in object and image forms. So what is the hybridization of central atom? If it is existing in object and image relation, then you can conclude that it is a tetrahedral and hybridization is sp3. And if they say M, A, B, C, D is existing in 3 isomeric forms, then you can conclude it must be square planar and hybridization must be dsp2 like. Next we have seen that Ma4B2 type, here they give tetraamine cobalt 3 chloride complex, and this exists in cis and transform. The Cls are close by, cis form, and this is 2 Cls are farther away, transform. And these molecules can be cut into 2 equal parts, therefore they are not optically active. And we have seen in detail also, if you recollect, this is the diagram we have seen. This is a cis molecule, and you can see when it was rotating that you can cut it here, cut it in this plane to get 2 equal parts. Also you have seen that this is trans isomer, and it also can be cut into 2 equal parts. It is also not optically active. We have seen all this. And then our NCERT book talks about the isomerism in octahedral complexes where there are 2 bidentate ligands. This is of course bis ethylene diamine. 2 ethylene diamine groups are there. Ethylene diamine has NH2, CH2, CH2, NH2. Points of linkage is nitrogen. It is 2 Cls are close by. Therefore, it is dichloro bis ethylene diamine cobalt 3 chloride, where it is in cis form. If they are farther away, it is in trans form. And this trans form can be happily cut into 2 equal parts, so it is not optically active. But generally and wherever there is a possibility, cis forms are optically active. Therefore, this cis form can exist in D and L forms. That is, it has 2 isomers, D and L, and it is another one. Total number of stereoisomers for this dichloro bis ethylene diamine cobalt chloride is 3. 2 are geometric, and these 2 are geometric isomers, and cis itself can have D and L, 1 pair. Now Ma3B3 type, they have given trinitrito-N triamine cobalt complex ion. In this, it can exist in facial and meridional forms, and these 2 cases also we have seen earlier. One particular interesting case as per the NCERT book is, if it has 3 bidentate ligands, MAA taken 3 times, now this can never show geometrical isomerism, but this fellow can exist as object and image forms which are non-superimposable. Therefore, this can be seen like this. You will be wondering, sir, I can cut this into 2 equal parts like this. I can cut this into 2 equal parts like this. How the hell it is optically active? You can generally ask that question. Now you can see that. In 3D, if you see, if I am trying to cut like this, I will never get 2 equal parts. If I try to cut like this, I will never get 2 equal parts. If I try to cut like this, I will never get, in any way I can't cut it into 2 equal parts. This is the metal, these 3 are bidentate ligands. So it clearly points out that this MAA taken 3 types complexes. Here they give tris oxalate of cobaltate ion. This can be tris ethylene diamine platinum. It can be anything, MAA taken 3 times complex ion is optically active. It never shows geometrical isomerism, of course. Now you will be wondering, sir, what happens if they are not identical? It is ethylene diamine means NN. If they are not identical, what happens? We see to it, but at the moment I want to point out, to err is human and to forgive is divine. Every human being can commit some mistakes, right? So now you should be divine because there is an error here. They say this is ethylene diamine, dichlorobisethylene diamine dextroform. Its mirror image is levo form. But unfortunately in the textbook, this is wrongly printed. This is not levo form, it is the trans form which has wrongly been printed, so you should be divine to forgive them. Now can you think how the really levo form will be? It will be like this, no? It will be going away and then it will be going away like this, 2 Cls will come like this. This is a mistake, okay? This type of isomerism is seen in dichlorobisethylene diamine platinum complex, that is also MAA taken twice X2. Now you will be wondering, sir, if these two are identical, that is why you are saying 2 optical isomers, no geometrical isomers. Okay, very good. Of course, this can show 2 optical isomers and this is wrongly printed. Cis isomer can show optical isomerism. It's a trans isomer they have discussed earlier. This can never show optical isomerism. We have seen all that. Now you will be wondering, sir, if both are different, as in this case, you can see here M X2, here X is water, and it is AB taken twice. It is glycineto. In glycine, one end is nitrogen, another end is oxygen. Therefore, in glycineto complex, how many such isomers exist? Because here situation become a bit difficult because of different orientations. If it is MAB taken twice X2 type complex, total it can show 8 stereoisomers, the discussion of which is beyond the scope. But anyway, just I wanted to give you an idea. Okay. Now this is a note on optical isomerism as seen in complexes. Next, I gave a textbook question, draw the structures of geometrical isomers of FeNH2 taken 2 times, CN4 type, Ma2 B4 type. You can think same thing, right? Out of the following 2 coordination entities, which is chiral optically active? You know, as a rule, cis isomers are optically active in MAA taken twice X2 type. It's also obvious. Again, the same mistake has, this is cis. They have not given its image, it is trans. Out of the 2, cis is chiral. That is very important. So this is a quick note on the stereoisomerism as seen in coordination compounds as far as the 12th class portion is concerned. In fact, the subject is much wider and deeper, but anyway, that's enough. We need not have to catch the ball crossing the boundary. Okay, with that note we conclude. In the next brief session we talk about the structural isomerism. Thank you very much. God bless you.